Sequences. When we talk about sequences, we discover that things around us, regular things around us, follow regular patterns. For example, we arrange things in such a way that we can easily predict the next values. Days of the week, we arrange them Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, all over again, such that we can easily predict what the next day will be, what the next 3 days will be, and so on. Okay, so if we arrange things in such, we say that they follow a particular sequence. Okay, now when we count even numbers or odd numbers, we realize that they follow similar patterns. For example, even numbers, we say 2, 4, 6, 8, 10. So we know that we can predict that the next numbers will be 12, 14, 16, and so on. Okay, so these are sequences. Okay, to define sequences, we can say a sequence is a progression of numbers according to a particular pattern so that it is possible to predict the next values. Okay, so these are things that we can talk about sequences. Well, let's take some examples. Talking about examples, we can have 1, 2, 3, 4, 5. Now, if you look at this carefully, you can predict the next values as 6, 7, 8, 9, and so on. Okay, 2, 4, 6, 8, 10. So all these are examples of sequences. Now, if you look at these sequences, you realize that some of them are proceeding by addition of certain values like 5, 10, 15, 20, 25. You see that it's proceeding or it's progressing by addition of 5. Some of them are progressing by subtraction like 20, 17, 14, 11, 8. You see that they are progressing by addition of -3 or subtracting 3. Okay, then others proceed by multiplication like 3, 6, 12, 24, 48. This proceed by multiplication of 2. 3 times 2, 6. 6 times 2, 12. 12 times 2, 24, and so on. Okay, then look at the last one. They will have 8, 4, 2, 1, half. You see that they're proceeding or they're progressing by multiplication of half or division of 2. Okay, 8 times half, 4. 4 times half, 2. 2 times half, 1, and so on. Okay, so these are some examples of sequences. Now, the sequences can be grouped into those that proceed by addition or subtraction. We refer to them as arithmetic sequence or arithmetic progression. In short form, we can call it an AP. Then those that proceed by geometric sequence, we refer to them as geometric progressions. Okay, those that proceed by multiplication and division, we refer to them as geometric sequence or geometric progression. In short form, a GP. Okay, now let's focus on AP. Now talking about AP, if you look at the arithmetic progression 2, 4, 6, 8, 10, you realize that they're progressing by addition of 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. So you see that 2 is a common difference. So we can refer to 2 here as the common difference, which will help us to predict the next values. So if I want to predict the next values, I will say 10 plus 2, 12, and so on. Now if you look at the second one, you see 3, 3 and a half, 4, 4 and a half, 5, and so on. So the common difference there is half because they're progressing by addition of half. 3 plus half, 3 and a half. 3 and a half plus half, 4, and so on. So the difference between the term is constant, hence we can call it the common difference. Now, if we're looking for the next term or the next two terms, it's very easy to use the common difference. But what if you're looking for the next 100 terms? You see that it will be difficult to repeatedly add the common difference. Hence, we need a formula that can help us to answer that. Now, to derive the formula of an AP, we can say if the first term is A, let's take the first term as A, and the common difference as D. And the number of terms that we're looking for, let's say the 10th term, 11th term, 20th term, that's the nth term. Okay, the number of terms here is n, and that nth term, the value of the nth term is an. Then for any AP, we can say that an is equal to a plus n minus 1 bracket d. This is the general formula for solving problems on AP. So if you're looking for nth term of an AP, you can say an equals a plus n minus 1 bracket d. So if I'm looking for the 100th term, I can say A100 is equal to A plus 100 minus 1 bracket D. Example, find the 13th term of the sequence 1, 3, 5, 7. Okay, so if A, the first term is equal to 1, and D, the common difference is equal to 2, look at it. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, 2. That shows that the common difference is equal to 2. And n is the 13th term. We're looking for the 13th term, so n is equal to 13. Okay, now the value of the 13th term, an, is equal to a plus n minus 1 bracket d. So a13 is equal to 1 plus 13 minus 1, or bracket d. That's or bracket 2. Now, A13 is equal to 1 plus 13 minus 1 is equal to 12. So 12 times 2, that gives us 24. And 1 plus 24 is equal to 25. So the 13th term of an AP is equal to 25. Okay. Then, talking about geometric progression or geometric sequence, we say that these ones normally proceed by a common ratio, that's by multiplication or division. For instance, 2, 4, 8, 16, 32. If you look at them carefully, you realize that they proceed by multiplication of 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So if we want to predict the next term, we can say 32 times 2, 64. The same can be applied to the second sequence here. 5, 15, 45, 135, 405. So the common ratio there is what? 3. So the ratio of multiplication or division between the terms is constant, hence we call it the common ratio. Now, if we want to predict the next term, we can easily do that. But what if we need to predict the next 20th term, the 20th term, or let's say the 100th term? Then we need a formula as well for the geometric progression. Okay, to derive the formula, here we have, if the first term of the GP is A, and the common ratio of the GP is R, and the number of terms in the GP is N, then the nth term of the GP, the value, let's say is Gn. Then for any GP, Gn is equal to AR raised power n minus 1. Okay, so if we're looking for the 20th term, we can say G20 is equal to AR raised power 20 minus 1. Let's take an example. Find the 7th term of the GP. 7, 4, 14, 7, 14, 28, 56. Okay, and to solve this, we can say A is equal to 7, since 7 is the first term. And the common ratio R is equal to 14 over 7, which is 2. To show that it's common ratio, 28 divided by 14 is also 2. 56 divided by 28 is also 2. So the common ratio is 2. And the number of terms we're looking for the seventh term. So n is equal to 7. So the value of the seventh term, gn, is equal to a raised to the power n minus 1. So G7 will be equal to 7 times 2 raised to the power 7 minus 1. So that's the same thing as 7 times 2 raised to the power 6. And don't forget, 2 raised to the power 6 here is the same thing as 2 times 2 times 2 times 2 times 2 times 2. That is 2 into 6 places. So that's 7 times 64, which is 448. Now for more examples on sequences and also explanations on a series, you can follow us at Smart Learning to learn more. Thanks.